Hi, everybody. So, you've been tasked with passing the Keystone. I am even going to take it a step further and say that you can get advanced on the Keystone. I believe in you. So, this is how we're going to have class up until the end of the school year. Well, up until we all have to take the Keystone. So, I believe the math, Algebra 1 Keystone exam will be on the 12th of May. So this is what we're going to do, and this is how I'm going to grade you. I am going to provide you with a rubric so that you can see how I expect to see what you can do so that you are better prepared for the Keystone exam. I'm also going to teach you, hopefully on your computers, how to do open-ended questions by typing, because you have to type your answers. So you have to write and then you have to type, which is writing. Okay, so we are going to get started. I am going to, again, like I said, I'm going to show you what I expect you to do. I'm going to try to give you step-by-step instructions, but I am going to be grading you based on what I see you do and how you improve over time so that you do well on the Keystone. Okay, so let's get started. Okay, so I'm not sure how many of you pay attention to the formula sheet at all, but there are some formulas on here. The slope formula, point slope formula, slope intercept form, standard form. I'm not sure how many you would use on the Keystone exam, but you really should understand what all of them are for. Formulas that you may need to solve questions on this exam are found below. You may use calculator, pi, or the 3.14 number as an approximation of pi. And then the additive inverse just means if you add an opposite number to itself, you get 0. It's just basically 1 minus 1 or 2 plus a negative 2. It's the same thing, and you end up with 0. Here, if you multiply a reciprocal times itself, you get 1. This is just showing you that if you add 1 plus 2, you get 2 plus 1. Same thing with multiplication and so on, okay? So, again, if I can refer back to these, I will, just to make sure that you know what they're used for. All right, so I'm just going to do a couple of questions from this each time, okay? So here we're talking about values, right, of A, which is some number, that make this inequality true, okay? So if I do something like the square root of, let's say, 0.15, right? And if I put that into a calculator, let me get my calculator. So if I take the square root, it's not going to, first of all, it's not going to be A equals 0. It will never be that. So let's say 0.15. And then if I take 0.15 and I square it, I'm going to get a smaller number, okay? So definitely not, it's not going to be that one. Definitely not that one, okay? Because the square root of 1 is 1 and it's not bigger. So this is saying larger, right? So because you are going to be writing these in your notebook, since it's from module 1, I want you to write yourself some notes. Like, so for instance, I said, this symbol is greater than. Okay, so if this one's greater than, the other one's less than. And you're reading from left to right. So I'm comparing the left side to the right side. That's L for left and R for right. Okay, so if I do the square root of, and the square root of 0.15 is my A. So A is equal to 0.15. So remember that. And then if I take the square root of that, I'm going to get 0.38. Okay. But if I do 0.15 squared, I get 0.0225. And this is smaller. Oops, squared. This is smaller. So this would be, right, I could do a decimal between 0 and 1, and I end up with a smaller number when I square it. So for this one, it is going to be between 0 and 1. Okay, so if you look at the explanation, it says that a student could determine the correct answer, option C, by recognizing that when the square root of a number between 0 and 1 is determined, the result is larger than the original number. Okay, so the square root of 0.09, and you have your calculator, so I'm walking around to see you doing this on the calculator. I want you to type in the square root of 0.09, and that's equal to 3, and that's greater than 0.09 squared. Okay, so you see here, there's the example right there. Okay. So that's all we're going to say about that one. Okay, let's go to the next one. So it says, which expression can be simplified to the form x times the square root of 3, where x is an integer? So all of these can be divisible by 3, right? So if I divide 48 by 3, I get 16. If I do 51 divided by 3, I get 17. If I do 54 divided by 3, I get 18. And then I get 50. If I do 57 divided by 3, I get 19. Okay, so it's saying where x is an integer. Really what it's saying is, right, if I simplify a number, so if I have the square root of 48, that is equal to the square root of 16 times 3. Okay, I'm going to get 4 times the square root of 3. This is 4 times the square root of 3, which this could be x. And then with the only one that I would maybe want to check is the square root of 54. 54, which is the square root of, what does it say here? 18 and 3. But if I try to break up 18, I get 9 times 2 times 3. And that would not, if I do the square root of 9, it would be a 3 out here, but then there would be a 2 left here. So the only one that it could be is the first one, which is A. It can't be either one of these because I can't do the square root of 19 and I can't do the square root of 17. So those are not possible. Okay? So if you look here, and I want you to write yourself a note. I'm coming to check right now. I want you to write yourself a note of why A can be the only one that's the answer. Okay? Their explanation is a little bit different than mine, but that's okay. Mine, I feel like, is a little bit simpler. Okay? All right, and then we're going to do one more. So we need to go over factoring big time, okay? Factoring is not hard. It is just the opposite of multiplication. It's not necessarily division, but it can be considered division, okay? So when you're writing factors, if you see the square here, and I want you to write the whole thing down. When you factor, that x squared is the first two terms in each binomial is going to be x and x. And then you need to use the number, the last term, which is 24, and you need to write down the factors of 24. And I think I have all of them, okay? And then you need to decide which two numbers, no matter what the signs would be, would give you a 2, okay? The only ones that it could be are 4 and 6. So it could be -4 plus 6, or it could be 4 minus 6. The middle term is negative, so you have to use 4 minus 6 because that's the one that's going to give you the -2. So when you put them inside here, you have one that's going to be minus and one that's going to be plus. So the 6, well, I usually write them in order, but I'm going to put the 6 there and the 4 there because it really doesn't matter. And then when I multiply them back, I get x times x. Outside is plus 4 times x. Inside is minus 6 times x. And then last is minus 6 times 4. So I end up with x squared minus 2x minus 24. So that means I need to choose over here any ones that match these two. And the only one that matches is x minus 6. There's other ways to determine this, but I'm going to check to see that you wrote yourself some notes. Okay? And then there's the explanation. And the explanation pretty much matches what I said. Alrighty. So we are finished with this part. Now we're going to go to your Keystone coach books. Okay. So on page number 10, where we were supposed to start the other day, we are just going to glance over comparing and ordering real numbers, okay? So knowing whether it's a natural number, integers, that's not particularly important. Unless, of course, the test asks you that. What's important is for you to know or approximate where numbers are on this number line, okay? So they're going to give you a list of numbers, and they're going to say either from greatest to least or least to greatest. So you have to know how to order these. Now, if you're able to use a calculator, you can easily put 3 plus 1 divided by 8. And it's going to give you 3.125. So that number is going to be the lowest number. But you're not sure, you just need to situate it. Sorry, it's here. So it's here, okay? And then that number is right here. Sorry, I was getting confused with this negative. Didn't even notice it. Okay, so 3.125 is here, just right above the number 3. Then 3.14, which is pi, so you can even type, where is pi on here? I'm not used to this calculator. Where is pi? Right there. So if you do that, you're gonna get the 3.14159, that's right there. And then the 3.92 is there. So you just need to take your time and situate these numbers. So negative square root of 6. Remember, if you have a negative in front of a number, you need to do that negative here, not minus. So that's all the way over here. And then negative 3.1 is the first number. Okay? So you gotta be really, really careful. All right? All right, so on to the next one. That is how you list them, okay? And then you have your example number 2. And because these are written in your book, you don't have to rewrite them, but I would like to see you jot some notes about how you would go about ordering the numbers. So for me, this one right here, I don't need a calculator for the first one because I know that half of $9 is 4.5. Half of $9 is going to be because okay, so for this one, I know that half of 8 is going to be 2, so it's going to be somewhere around 2. So I can just do 9 divided by 4. Hopefully you can see this. And you get 2.25, and then you do the square root of 5. And you would definitely need a calculator to do this. If by chance you did not get a calculator to do this, you would know that the square root of 4 is 2. So the square root of 5 is going to be between the square root of 4 and the square root of 9. But you would definitely need a calculator to figure out that decimal. So which one is larger? It would be 2.25. Okay? And then please make sure that you read the solution and why it is, or how you can figure out if it's true or false. Okay? This inequality, x cubed is greater than or equal to x squared, true for all real numbers. Inequality is the inequality x cubed greater than or equal to x squared, true for all real numbers. All right, so I would say yes, but in this example, if we use whole numbers, then yes, it is true. But if we use fractions, as you can see here in this negative, and the negative's outside, so this is actually a little bit tricky because when the negative's outside, it stays negative. So that's a little bit of a mistake, in my opinion. because this is not positive. If this one is outside and it's outside, the only time that you would change this is if it's inside the parentheses. So, that's a little bit, I'm going to bring that up to someone as well, because it's a little bit of a mistake. But it says the inequality x cubed is greater than or equal to x squared is not true for all real numbers. And it says here the inequality is not true when x is equal to negative 1/3, since any negative number to the third power always results in a negative number. This inequality is not true when x is any negative number. Again, a little bit of a mistake there. Okay, so it says here, how can you write negative square root of 5? I'm not going to read all of those. And order it from greatest to least. So how do you express negative square root of 5 as an approximate decimal to 3 places? So use your calculator. Do that right now. Right, in inequality, compare that the decimal and negative 2.31. So you just write what you got for this one, and then you compare. It's either one number is going to be greater than or less than the other. How do you express this as a decimal? Put it in the calculator. Write an inequality to compare that decimal to these two. How do you express negative 1.3 as a decimal to the third power? Sorry. Write an inequality to compare those three. And then how can you write these 4 decimals in order from greatest to least? Okay? So I am going to do number 1. I am going to do number 7. So I'm going to do number 1 and number 7. Number 5. Okay? And then it is up to you to do the rest. Okay, so which is ordered from least to greatest? So if I just look at this as I glance at it, let's see. That would be negative 2 point something. So that's not right. That one's definitely not it. This would be 3.25. This would be square root of 4. This would be a little bit more than, see, because if I did 2, that would be 4. So this would be 3 point something. So it's definitely not that one either. 3.14, negative 3.14 divided by 4. This is negative 1.5. This is negative. Nope. Because this is, if this is negative 2 point something and this is negative 1.5, it's not in the right order. This is not going up. It's going all over the place. And this one is, this one I think would be worth doing in the calculator. So, negative square root of 10 negative 3.16, and then negative pi divided by 2. See, I'm going closer to 0. And then the next one would be 0.75, so 3 divided by 4. And then 0.81, so it would be D. All right. I'm going to pause the video and I'm going to watch you do 2, 3, and 4. So what I want you to do, if you have no idea what to do, is to see based in the calculator which one is true. So is this equal to that number? Put it in the calculator. Put that in the calculator, see if it's less than 2. Put that in the calculator, see if it's greater than 1. Put that in the calculator, see if it's less than the square root of 5. Okay? Same thing with all of these. See where they fit. All right. Same thing here. See which ones you can put in there for x and it would make it true. Don't forget you got to multiply 2 times that, whatever you substitute. Which of the following does not belong to the set of real numbers? So this is not a real number. We did complex numbers. This one would actually be 4i. That's not a real number. That's an imaginary number. Okay. I'm going to do number 7. So you get to do number 6. I'm going to pause the video so you do number 6, and I'm going to do 7. Which of the following inequalities is true when x is equal to 2? So I'm going to see if I can write all of that here. So I know that 2 to the 3rd power is 8. So 16 plus 5 is 21. Is that greater than 3 times 4, which is 12, plus 10? Nope, because this is 22. So it's not that one. This will be 4 times 4, which is 16. Is that greater? No. They're the same thing, so that's a no. Is 2 times 4, so 4, is that greater than 2 plus 1 to the 2nd power? So that would be 9. So no. It's less than 24. Oh my goodness. So it is D. Okay. So your job is to do 8 and 9, and I'm going to watch you do it. I want to see you help each other, and that is how I'm going to grade this lesson. This is lesson 1, comparing and ordering real numbers.